Your FastMCP server runs locally, but Gemini CLI needs to find it. How do you bridge that gap without hard-coding paths or manual setup? We'll see exactly how to register servers with custom configurations, environment variables, and scope control using Gemini MCP add. The commands you're about to see handle everything from dependency isolation to runtime settings, all in a single line.
Add a server with custom configuration. Gemini MCP add dice roller UV. Run with FastMCP run server. Add with environment variables. Gemini MCP add weather server. EAPI KEY equals secret debug equals true UV run with FastMCP run server. Add with specific scope, user or project. Gemini MCP add my server scope, user UV. Run with FastMCP run server.
This demonstrates the command composition pattern for integrating local services with external systems. The examples show how to package a Python-based FastMCP server as a managed command, complete with dependencies and environment configuration, while abstracting the execution details behind a standardized CLI interface. The distinctive aspect is the separation between the server's functional code and its operational context, allowing the same server logic to run in different environments with varying requirements. The pattern works by layering configuration through command chaining, where each component handles a specific concern. The inner command, FastMCP run server, PI, defines the core execution, while outer layers, UV run with, environment variables, scope flags, progressively add context like dependency isolation, runtime environment, and deployment targeting. This composable approach follows the Unix philosophy, small, focused tools that combine powerfully, while maintaining clean separation between the server's business logic and its operational constraints. This matters because it solves the "it works on my machine" problem for service integration. By encapsulating the server's execution environment within a reproducible command, you eliminate implicit dependencies and configuration drift. The pattern is particularly valuable for AI tooling, where local development must seamlessly transition to managed execution environments, and for teams needing to share tools without manual setup instructions. The trade-off is initial command complexity, but the payoff is deployment consistency across different systems. Let's break it down line by line.
Add a server with custom configuration. Gemini MCP add dice roller UV. Run with FastMCP run server.
This registers a new server named Dice Roller with FastMCP's process manager. The UV run command launches the server using Uvicorn, while with FastMCP ensures the process integrates with FastMCP's lifecycle management, enabling AI tool discovery and remote control.
Add with environment variables. Gemini MCP add weather server. EAPI KEY equals secret debug equals true UV run with FastMCP run server.
This adds a server named weather server while injecting environment variables at runtime. The E flags pass sensitive configuration like API keys without hard-coding them, enabling secure deployment across different environments. This follows the 12-factor app pattern for environment-specific configuration.
Add with specific scope, user or project. Gemini MCP add my server scope, user UV. Run with FastMCP run server.
This sets the server's visibility scope to user, restricting access to only the current user account. Without this flag, servers default to project scope, which shares access with all project members. Use scope control when you need strict access isolation. FastMCP CLI integration. The Gemini MCP add Command bridges local Python tools with AI clients through environment isolation and dependency management, using the same at MCP tool decorator pattern we've seen throughout this series. Environment variables passed via E override any env file values at runtime, which can lead to silent configuration mismatches if not carefully managed. This CLI-first approach makes your tools instantly discoverable by any MCP-compatible client without modifying the server code itself.
The command that forgets its name becomes every command